Euclid's Elements, Book 3, Proposition 31. In a circle, the angle in a semicircle is right. That in a greater segment is less than a right angle. That in a lesser segment is greater than a right angle. Furthermore, the angle of the segment is greater than a right angle, and the angle of the smaller segment is less than a right angle. 5 things we're going to prove here. It's probably easier to do it with a picture. So let's have a circle. Let's have circle A, B, C, D. And let AB be the diameter. What we're going to show is that if we take an angle in, so this is an angle in the semicircle, this is going to be a right angle. And so, let me say this angle here. So angle 1, the angle in a semicircle, that's going to be a right angle. And if we look at this segment here, segment ABC, the angle here, angle 2 is the angle in this larger segment, and it's going to be less than a right angle. So angle 2 is going to be less than a right angle. And if we look at an angle in this lesser segment, here the angle at D, we're going to see that this is greater than a right angle. And furthermore, if we look at the angle created by the greater segment and the circumference, this angle here, and we'll call this angle 4. Angle 4 is going to be greater than a right angle. And if we look at the angle between the segment of the lesser and the circumference, we'll call that angle 5. Angle 5 is going to be less than a right angle. So those are the 5 things we're going to prove. So we'll save the blue angles for later. We'll just work with the red angles for now. So the first thing we're going to do is find the center of our circle. And let it be E. And we're going to connect. Let's see, we're going to connect CE here. And we're going to look at the various triangles that we have here. So remember, we're going to be looking at this, whole angle here as angle 1, but we're going to see it broken up into smaller. So, okay, so let's look at this triangle here. In this triangle, so the first step here is take the center and connect CE. And now let's look at the triangle. So in triangle ACE, we can see that this is a radius and this is a radius, which makes this angle and this angle equal to one another. And we'll call this angle small a, and we'll call this also small a. So the small angle's A, and angle A equals angle A. The small angles are equal to each other because they're base angles of an isosceles triangle. And so according to book 1, prop 5, those 2 angles are equal. Likewise, let's look at this triangle, triangle CEB. And in triangle CEB, we have an isosceles triangle. Therefore, this base angle, call this B, and this base angle, angle 2, they are equal to each other because same thing. Prop 5, book 1, isosceles triangle, base angles are equal. So angle B equals angle B. And as we can see, angle 1 is simply made up, right? Angle 1 is equal to angle A plus angle B. Now let's, step 4, let's extend BC as far as we wish over here to F. And let's take a look at this big triangle. So in triangle ACB, we have an external, one of the sides extended, and so we have an external angle here. And so we'll call that angle 6. And we have an external angle, angle 6. And we know from Book 1, Prop 32, that the external angle of any triangle is equal to the opposite and interior angles. Therefore, angle 6 is equal to angle A plus angle B. But angle 6, but angle 1, as we said here before, angle 1 is also equal to angles A and B. Therefore, angle 1 is equal to angle 6. So angle 1 equals angle 6. And so we have a situation where we have a straight line set upon another straight line making two equal angles. And that means, by definition, so if we look at Book 1, definition 10, when we have this situation where we have a line set upon a line making these two angles equal to each other, then both of those angles are right. Therefore, angle 1 is a right angle, and angle 6 is a right angle. And that's the first thing we're trying to prove, that angle 1 is a right angle. So let's replace all of this with this new truth. Angle 1 is a right angle. And also angle 6 over here is a right angle. Now let's take a look at, let's go back to triangle ACB. We know that this is a right angle, and therefore we know that from Book 1, Proposition 17, tells us that any two angles taken together in any manner have to be less than two right angles. So this plus this has to be less than two right angles. So angle 1 plus angle 2 has to be less than two right angles. But since angle 1 is already a right angle, then the remainder, angle 2, has to be less than a right angle. Therefore, angle 2 is less than a right angle. And that's the second thing that we've proven. Now let's take a look at our quadrilateral. We have a quadrilateral A, D, C, B. And in our quadrilateral, we know when we have a quadrilateral, Book 3, Prop 22 tells us that the opposite angles in quadrilaterals are equal to two right angles. So if we take two opposite angles, for example, angle 2 and angle 3, we would know that angle 2 plus angle 3 together equal two right angles. But we already know that 2 is less than a right angle. Therefore, in order to get to two right angles, angle 3 must be greater than a right angle. And that's the third thing we're going to prove there. So now we've proven angle 1 is a right angle. It's the angle in a semicircle. Angle 2 is less than a right angle, and that's the angle in a greater segment. And angle 3 is greater than a right angle, and that's the angle in a lesser segment. And now we just have to show that what we call angle 4 here is greater than a right angle, and what we said here was angle 5 in blue here is less than a right angle. And this is immediately manifest because angle 4 includes angle 1, which is a right angle, and this extra. So it's going to obviously be greater than a right angle. And angle 5 stops well short of angle 6, and therefore it has to be less than a right angle. Therefore, in a circle, the angle in a semicircle is right. The angle in a segment greater than a semicircle is less than a right angle. The angle in a segment less than a right angle, less than a semicircle, is greater. Furthermore, the angle of the greater segment is greater than a right angle, and the angle of the lesser segment is less than a right angle. And those are the 5 things we're given to prove, and so we can conclude with QED.